Assalamu alaikum warahmatullah. Inshallah, we will continue solving paper 42, May-June 2021. Let's start. Question 5. This question is about compounds of nitrogen. Nitrogen react with lithium to form lithium nitride. Write the chemical equation for the reaction between lithium and nitrogen. This equation is for 2 marks. 1 mark for correct formula of the reactant and the other mark for balancing the equation. Lithium nitride is ionically bonded. Complete the diagram to show the electronic structure of the nitride ion and show the charge on the nitride ion. Nitrogen atom is non-metal atom, so it will form a negative charge ion. It's in group 5, so it has 5 electrons in its outer shell. It needs 3 more electrons to complete its outer shell to 8. So it will accept 3 electrons from 3 different lithium atoms, and the charge here will be -3. You have to choose 2 different symbols, one for the electrons that comes from nitrogen atom and the other symbol for electrons that comes from lithium atoms. Question B. Nitrogen react with fluorine to form nitrogen trifluoride, and the chemical equation can be represented as shown. Some bond energy are here in the table. Calculate the energy change for the reaction between nitrogen and fluorine using the following steps. Energy taken to break the bonds is the energy needed to break the bonds of reactant. Here we have 945 for breaking the bonds, triple bonds between nitrogen and nitrogen, and we have 3 multiplied by 160 for breaking the bonds between fluorine atom and 3 fluorine molecules. It will be 1425 kilojoules. Energy released when forming new bonds. Here we have 6 nitrogen fluorine bonds, so we will multiply this 300 by 6. It will be 1800 kilojoules. Energy change during the reaction is the energy needed to break the bonds minus the energy released to form new bonds. The answer here will be minus 375 kilojoule per mole. Use your answer in I to deduce whether this reaction is exothermic or endothermic and explain your answer. Definitely you have a negative number, so the reaction is exothermic because the energy released in formation of new bonds is higher than the energy needed to break the bonds of the reactant. Question 3. Complete the dot and cross diagram to show the electronic arrangement in a molecule of nitrogen trifluoride. Use dots for nitrogen electrons and crosses for fluorine electrons. Here 3 marks. 1 mark will be for the 2 non-bonding electrons for nitrogen atom, and the other mark for 6 non-bonding electron in fluorine atom. The 3rd mark will be for correct covalent, 3 covalent bonds between nitrogen and fluorine. Nitrogen has 5 electrons in its outer shell. 3 electrons will be used in 3 different covalent bonds with 3 fluorine atoms, and 2 non-bonding electrons for the nitrogen atom. Fluorine atom has 7 outer electrons. It will share 1 electron to make 1 covalent bond, and each fluorine atom will have 6 remaining non-bonding electrons. Lithium nitride melt at 813 Celsius and nitrogen trifluoride melts at -206 Celsius. Explain in terms of attractive forces why lithium nitride has much higher melting point than nitrogen trifluoride. In your answer, you have to refer to the type of attractive forces between the particle and the relative strengths. So here you have to mention the type of attraction in case of lithium nitride and in case of nitrogen trifluoride, and say whether it's weak or strong, and refer that to the melting degree or the melting point that he mentioned in the question. So lithium nitride is ionic compound in which oppositely charged ions are held by strong electrostatic force of attraction which need high energy to break. Here you mentioned that's ionic compound and the ions are held by electrostatic force of attraction, and this is the mark needed here. Oppositely, you have to mention what's the type of bond in nitrogen trifluoride, in the attraction between molecules. In case of the covalent compound nitrogen trifluoride are weak intermolecular forces of attraction, which can be break easily, so it has low melting points. Ammonium nitrate is a compound of nitrogen. Calculate the percentage by mass of nitrogen in ammonium nitrate. Here first we have to calculate the relative formula mass of ammonium nitrate, which is easily calculated. 14 for nitrogen, 4 multiplied by 1 for hydrogen, another 14 for nitrogen, and 16 multiplied by 3 for oxygen. This will be 80. The total relative formula mass for ammonium nitrate. And the mass of nitrogen here, 2 multiplied by 14 is 28. So the percentage of nitrogen will be 28. Divide 80 multiplied by 100. This will be 35%. State one use for ammonium nitrate in agriculture. This is, of course, fertilizer. State the name of compound that will displace ammonia from ammonium nitrate. Ammonia is a weak base, so it can be displaced by a stronger base like sodium hydroxide, potassium hydroxide, and calcium hydroxide. And this reaction is used to test for ammonium ions. Where we are testing for ammonium ions, we displace ammonia by stronger alkali like sodium hydroxide, and the positive test is by smell the pungent odor of ammonia that is released. Question E. Ammonia is a base which form a weakly alkaline solution when dissolved in water. Define the term base. Base is a proton acceptor. Suggest the pH of aqueous ammonia. Here you can write any number between 8 and 11. It's good to write intermediate number like 10 or 9. Question 6. Molecule A and B can form condensation polymer. Each molecule has 2 identical function groups. Name the function group in B. It's carboxylic group. COOH. It's carboxylic group. Here, second one, draw the parts of the structure of these synthetic polymers that would form when the 2 molecules A and B combine. Show all bonds in the linkage. Here this drawing is for 3 mark. 1 mark for correct 3 ester linkage, and the second mark for correct order of the polymers, and the third mark will be for continuation of the polymer. You have to draw 2 bonds open, 1 from each side, to show continuation of this polymer. Name other product that formed when molecule A and B undergo polymerization. Here it's condensation polymer. In each condensation polymer there is a byproduct which is water that's formed, so the other product here is water. Question B. Molecule A is a simple sugar which can be made by hydrolysis of complex carbohydrates. Draw part of the complex carbohydrate that could be hydrolyzed to make molecule A. Include 1 linkage and show all the bonds in the linkage. The bond here in the complex carbohydrate, only O between 2 different blocks, and the O linkage in the middle, and you have also to leave 1 bond open from each side. State 2 sets of conditions which could be used to hydrolyze a complex carbohydrate to form sugar A. Carbohydrates can be hydrolyzed by 2 ways, either by acids or by enzymes. So this is the condition needed to hydrolyze carbohydrates. Name the technique used to identify the individual sugar unit made by the hydrolysis of complex carbohydrate. Sugars can be identified using chromatography technique. Question C. Ethanol can be made from the simple sugar glucose. State the name of this process. Ethanol can be made from sugar by fermentation. Complete the chemical equation for this reaction. This question is for 2 marks. 1 mark will be for correct formula of ethanol, and the second mark will be for balancing the equation. Here we come to the end of our exam. Thank you for watching. Wish you all best of luck.